Hi everyone, we are still in Chapter 1 Matter for the Subtopic 1.2 Mole Concept Part 1 Mole. Mole is an SI unit used to measure the amount of any substance. To get mole from the mass given, mass divided by molar mass. And to get mass from the mole given, mole times to the molar mass. Molarity. If you are given the molarity of a solution, molarity we refer to the concentrations of a solution, molarity times to the volume, then you will get mole. To get the molarity, mole divided by volume, and the volume must be in liter. Mole and number of the particles. Particles we refer to the atoms, or molecules, or ions, or electron. To get mole from the number of the particle given, divide by Avogadro number 6.02 times 10 to the power 23. If you want to get the number of particles from the mole given, mole times to the Avogadro number. Molar volume at STP. STP is the standard temperature and pressure. Temperature is 0 degrees C. In Kelvin, it is 273 Kelvin, pressure 180 m, and 1 mole any gaseous, it will occupy 22.4 liter. To get the volume of the gas from the mole given, mole times to the 22.4 liter. To get mole from the given volume of the gas divided by 22.4 liter. And we also have another conditions, which is we call it as a RTP, room temperature and pressure. Temperature is 25 degrees C, okay, and the pressure 180 m, and 1 mole of any gaseous, it will occupy 24 liter. Okay, let's see the relationship between the mass of a substance and molarity of the solutions. Okay. This is a method how to get mole from the given substance, mass of the substance, and molarity of a solution. For the example, if you weigh the zinc powder is the substance in the solid state, and the mass of the zinc powder is 0.249 gram. To get mole of the zinc, by using the formula, mass divided by molar mass. So the molar mass of the zinc you can get from the table of the relative atomic mass, and mole is 0.003808 mole. Remember, mole must be in 3 or 4 significant figures. Okay, here the example, you have to take 4 significant figures of the zinc mole. Next, to get mole from the molarity of the solution. For the example, I give you the apparatus for the titration. So let's say in the conical flask, there are HCl solution. So the HCl solutions, it has molarity 0.2 molar, and the volume of the solution is 0.0025 liter. To get mole from the molarity and volume given, okay, molarity times to the volume. So molarity 0.2 times to the 0.025 liter, then it is 0.0005 mole. So this is how you get mole from the given mass of a substance in the solid phase and given the molarity of the solutions. Avogadro number. So Avogadro number synonym to the mole of any atoms, molecule and formula unit. Okay, for the example here, okay, 1 mole of sodium, it consists Avogadro number atoms, because sodium, it only has one type of element. And carbon dioxide, you can see that it is molecule because it has more than one element. So in 1 mole of the carbon dioxide, it consists Avogadro number molecules. And the magnesium chloride is a ionic compound, so we use formula unit. In 1 mole of the magnesium chloride consists Avogadro number formula unit. And for the electrons, okay, 1 mole of electrons, it consists Avogadro number electrons. So this is how the relationship between the Avogadro number and mole. Okay, let's see the next example. 1 mole of the carbon dioxide. So as I told you, carbon dioxide is a molecule because it has more than one element. It has carbon and it has oxygen. So in 1 mole of the carbon dioxide, okay, it has Avogadro number carbon dioxide molecules because it is molecules. And to get the mole of the each atom of the element, carbon and oxygen, first you need to find mole of the carbon and oxygen. So in 1 mole of the carbon dioxide, it has 1 mole of carbon, and there are also 2 mole of oxygen. So in 1 mole of carbon, it consists Avogadro number carbon atoms. And in 2 mole of the oxygen, it consists 2 times Avogadro number oxygen atoms because there are 2 mole in the carbon dioxide. Okay. So actually carbon dioxide, they are in solid state, so this is an example, okay, of the solid carbon dioxide. If you put in the hot water, so it will become like this one. Alright, next. 1 mole of the magnesium chloride. It is the ionic compound. So how many ions? Magnesium 2 plus in 1 mole of the magnesium chloride. It has Avogadro number magnesium 2 plus ion. And how about the chloride ion? In the 1 mole of the magnesium chloride, we can see that there are 2 mole of the chloride ion. So ions, how many ions it have? 2 times Avogadro number, then equivalent to chloride ions. Okay, this is an example, pure magnesium flates, okay, magnesium chloride. Next, at STP, we know that the 1 mole of any gaseous, it will occupy 22.4 liter, and the temperature at the STP is 0 degrees C. In Kelvin, it is 273, and pressure 1 atm. So, okay, this is an example. 1 mole of the helium, it occupies 22.4 liter, and the mass of helium is 4 gram. That one is the molar mass, and the temperature, you can see that it is 0 degrees C in degrees C, but in Kelvin it is 273, and pressure 1 atm. Same for the oxygen gas. Okay, 1 mole of the oxygen gas, it will occupy 22.4 liter, with the mass or molar mass of the oxygen gas is 32.0 gram for 1 mole, and the temperature is 273 Kelvin, and pressure 1 atm. And same for the nitrogen gas. 1 mole of the nitrogen gas, it will occupy 22.4 liter at STP, and the molar mass is 28.0 gram nitrogen gas. Temperature same, and the pressure 1 atm. Alright, and another conditions, okay, room temperature, okay, which is the temperature is 25 degrees C, but 1 mole of gas, it will occupy 24 liter. So here you can see that all the balloons has 1 mole. Okay, for each balloon, it has 1 mole of the helium, oxygen, and nitrogen gas. So it occupied 24 liter because this is the condition at room temperature. And let's see the example. Okay, calculate the mass of the 7.528 times 10 to the power 23 molecules of methane. So CH4 is a molecule that consists more than one element. It has carbon and hydrogen. So it is molecule. And it needs you to find the mass for the molecules given. So theoretically, we know that 1 mole of the CH4, it consists Avogadro number molecules. So if given the molecule, this one, how many mole of the CH4? Okay, so this number value, okay, times to the 1 mole of the CH4 divided by Avogadro number for the 1 mole of the CH4. So you can see this is a conversion factor, okay, in the form of the conversion factor. Then you will get the mole of the CH4. After you get the mole of the CH4, you can calculate the mass of the CH4, which is mole times to the molar mass of the CH4. Carbon 12 and hydrogen 1, there are 4 hydrogens, so total is 16 gram per mole. So this is a mass of the CH4 for the 7.528 times 10 to the power 23 molecules. Okay, let's see next example. Carbon dioxide, given the carbon dioxide with the volume 56 cm cube at STP. So you should know that at STP, the volume is 22.4 liter, and the cm cube, you better to convert it into liter, which is 56 cm cube equivalent to 0.056 liter. Okay, first question, it asks you to calculate the number of the mole of the gas molecule. So by using the information given, okay, given the volume of the carbon dioxide, I already convert into liter, 0.056 liter. And okay, at STP, we know that 1 mole of the carbon dioxide occupies 22.4 liter. If 0.056 liter, okay, how many mole? It equivalent to how many mole? So 0.056 liter times to 1 mole of the carbon dioxide divided by 22.4 liter. So you will get the mole for the carbon dioxide is 0.0025 mole of carbon dioxide. Okay, next, after you get the mole of the carbon dioxide for the 0.0056 liter, next you need to calculate the number of the carbon dioxide molecule. We know that 1 mole of the carbon dioxide molecules equivalent to, okay, the 3 line here is stand for the equivalent to. So equivalent to 6.02 times 10 to the power 23 molecules. Or you also can use contents. Okay, you also can use words. Okay, just like 1 mole of the carbon dioxide consists or contains Avogadro number molecules. And if 0.0025 mole of the carbon dioxide, it consists how many molecules? Then this value 0.0025 mole carbon dioxide times to Avogadro number divided by 1 mole of the carbon dioxide. So this is a conversion factor, and then you will get that the molecule of the carbon dioxide, this value 1.505 times 10 to the power 21 molecules. Next, the last questions, okay, it needs you to calculate the number of the oxygen atoms in the sample. So basically, we know that from the carbon dioxide, okay, if I'm using 1 molecule of the carbon dioxide, it consists 2 atoms of oxygen. Okay, and you already calculate the molecule of the carbon dioxide in the second questions. So use that value to calculate the atoms of the oxygen. If there are 1.505 times 10 to the power 21 molecules of the carbon dioxide, it consists 3.01 times 10 to the power 21 atoms of oxygen. Or you also can use another method, which is find mole from the mole of the carbon dioxide, you find mole of the oxygen. 1 mole of the carbon dioxide consists 2 mole of oxygen. If there are 0.0025 mole of the carbon dioxide consists 0.005 mole of oxygen. So next, find atoms of the oxygen in the mole of the oxygen that you have calculated here. So theoretically, 1 mole of the oxygen consists Avogadro number atoms. If 0.005 mole of the oxygen, it consists, this value times to the Avogadro number divide by 1 mole of the oxygen. Then you will get the, when you cancel